everyone, and welcome to this week's Tech Talk. Before we get started, I just wanted to give a quick shout out to the Jakarta One live stream, the Cloud Native for Java live stream that's happening. So please, you can scan your QR code here to learn more about that. And also, we recently launched the JakartaEE YouTube channel. So there's a little call to action at the bottom of the video, but you can also scan this code if you want to subscribe and stay tuned for more content about the JakartaEE community. So today we have Cesar Hernandez and Rafael Guimaras, and they're going to be talking through the presentation. So I'll let them get started. You guys can take it away.
Thank you.
Let me.
Okay, great. Let me share my screen here. So thank you, everybody who's watching the live session, and also the recording on the different platforms. Thanks to Eclipse Foundation and the JakartaEE community for allowing us to have this space today. Let me share my screen, and we are ready to start. Okay, so can you confirm that you're seeing my screen right now? The session for today is keeping Brazilian medical industry safe with MicroProfile JakartaEE. Let me introduce myself and also welcome Rafael. You can introduce yourself.
Hi, my name is Rafael Guimarães. I'm a software engineer here in Brazil, south of Brazil. And we have a company, GBR Systems, with more than 25 years experience in medical and judicial areas in Brazil.
Okay. With Rafael, you're reading my background. My name is Cesar Hernandez. I am a senior software engineer for TomEE. I am actively involved in the open source Java side of the fence. I am Apache and committer, and also Eclipse committer for JakartaEE, and also a MicroProfile contributor. When we start planning this session, it was by the end of 2019. We didn't know that we were presenting this session with the current situation that it is happening around the world. So feel free to send our questions. You have two options in the platform. In the Crowdcast platform, you have the right side panel for general chat among the participants, but there is also a section just beside that one that you can say the questions and answer, and we will be moderating the question during this session. So the agenda for today is pretty straightforward. We are gonna review with the help of Rafael to understand the Brazilian healthcare system, the overview, how the base system that they have been performing, as Rafael mentioned, since the last 25 years had been evolved, and what was the main reason this movement to partially send some of the services into the cloud and with the modern technologies was approached by Rafael and his team. We added for this presentation what was their COVID-19 response, and what was the role in the system and the changes that they need to make or system that they need to create in a very short period of time in order to respond to Brazilian healthcare system needs. And finally, some lessons learned. We don't want to we don't want to extend too much this session, but as soon as you have a question, please send it, and we will be addressing them as we go. Without further ado, please, Rafael, you can start.
Okay. Hi for everyone, and I'm showing to you a little bit about the Brazilian healthcare system. So This is the next, yes. So we have the 5th largest country in the world and the 6th largest population, with more than 200 million people and 500,000 doctors to provide healthcare to those people. Next. And we are divided in 5 more major regions, 26 states with more than 5,000 cities. So very complex country. And we have a more concentration in Southeast and Northeast. So this is important information. The World Health Organization recommends 1 doctor per 1,000 people. Only south of Brazil has this indicator. So the rest, we don't have this situation. So our healthcare system is very difficult to maintain, and we have to deal with many problems, especially now in COVID-19 pandemic.
So, yeah, and one question that I have for you, Rafael, this data is evolving right now with the current situation in terms of, if we translate that into non-functional requirements, that means that if they are recruiting more, doctors and so on, then the capacity of the system should be able to handle this. Are you already have seen any spikes in the performance of the system? Is something that is
some echo, and I didn't understood the final.
Yeah, don't worry. I had my mute the microphone. So in terms of non-functional requirements, when we are talking about the system capacity, I recall that you were mentioning also that the systems are keeping a not common growth and not a common spikes in terms of usage, right? So right now are uncommon situations in the systems, and your team has to be working with this, right?
Yes, I'm gonna show at the end our solution for COVID-19 response, and I check now, and we had more than 20,000 prescriptions made in the systems in 2 weeks. So lots of doctors using the system. So we have some inequalities here. When the budget for the health is 25% for private health or supplementary health. So this is another problem that we have here in Brazil. So I'm gonna show here the main actors of those systems. We have medicine schools and residency problems that the people becomes doctors, and then we have the main practice that we call medical practice. Doctors make consultations to patients in some place. So government must control, regulate, create policies, make sanitary surveillance over this medical practice. And on the other side, we have the Medicine Council. So it's the place of the counselors made the professional discipline ethical judgment, keep their records, making inspections, and things like that. And there is the place that we work. The next. So, at summary over here, we have large and complex system with many inequalities. Governance is very difficult. More than 30 medical specialties, 20 types of health service providers, high frequency of policy and rule changes. This is one of the worst things that we have to do. So our microservices architecture help us with this high frequency of rule changes. Next. So how and we start to think how to make a good quality inspections with agility, especially considering a high amount of laws, recommendations, policies, and standards, and to create good statistics of those reports. What could be done to facilitate interactions between the doctors and the council? So the actors must check what service providers or doctors are working irregularly. What about the advertising? Here in Brazil, we have many problems with that, with wrong advertising. Oh. Next. So our company, we create 10 years, 11 years ago, and especially to deal with this kind of these situations of this business. We felt that they doesn't have something good to respond that questions. Next. So our base system is at the Federal Council with the National Inspections Platform. And there we can make scheduling and control execution. We have dynamic forms with checklists, images, photos, notifications, and can make reports and statistics, and make many integrations with the other parts of the government. And at the regional level or state level, we deal with the life cycle of the doctors. That begins when they start to practice medicine up to retirement. So in this system, they can make the first registration, transfer between states, make payments, get certificates, profile update, and many other things. And then we have to talk to you about our platform of accreditation. It's like a validation of the schools of medicine. So we have here technical view. We are using JavaEE 6, JBoss 7, Tomcat 6 and 7, and the client Adobe Flex, Adobe Air, Angular JS 1. We make that data integration with Cattle, and then we start to move to the cloud. So here is a summary of our coverage. We have the biggest one is the capital of Brazil, and we have in south Santa Catarina and Rio Grande do Sul state our system. This is some print of the system, one dashboard of the national inspection systems. This is old dashboard. Here we have 13,000 inspections. Today we have almost 50,000. So we are looking to improve the overall system architecture. So moving to JWT 6 to Jakarta 8, put security, more fault tolerance, performance, and monitoring. And then we are using API gateway with OAuth 2 security, microservice monitoring and routing, and integrations.
This section about I think you don't see the last two bullet points because of the images, but one of the newest requirements because this is a living system that has been evolved over the past more than 10 years or so. Initially, when the requirement started to migrate to the cloud without this cloud native approach, let will say that the requirement came like 2 years ago, but it actually started, like in most of the governments in Latin America, it takes a little bit of time from the idea to the actual realization of the system. So eventually, one of the latest requirements became to be let's make it cloud native, some part of the systems, but also the ability to support and test and prove different cloud providers. Because as Rafael was mentioning, even though the system tries to the main objective is to centralize the management, the reports about the healthcare systems, and how the doctors and now how the prescriptions are being processed and secured. Each state also has different requirements, even though it's the entire government. So being able to support different cloud platforms is one of the top requirements that this year started to appear, right?
Yes. In south state, Rio Grande do Sul, we create our cloud over there. We installed the system with VMware, and they wanted the system runs inside their infrastructure of their cloud.
So it was an on-premise cloud
deployment. On-premise cloud. In Santa Catarina, we are using Google Cloud. And maybe Federal Council use Azure Cloud.
Right.
We don't know yet, but we are checking.
Yeah, and the last requirement that you don't reach to read in the presentation is this is the very root of the project, being able to connect with different third-party, how we say it, APIs, other institutions, bank systems, and so on. In this case, pharmacy, like this year, was a requirement from the beginning. And the architecture, as you are seeing here, the roadmap allowed to have easily integration and with security in mind. So that is something that the benefit were reflected early this year, a couple of months ago. So Rafael will also give us a little bit of that.
Mm-hmm.
Okay. In terms of how we boost, as we like to call in the team, the system that we have already with all these technologies that you're reading here. For all of those that is maybe the first time that are joining this type of sessions, I think you all have heard about JakartaEE, and since the last 2 years, we now call it JakartaEE. So you are seeing here one of the flags. The main flag of JakartaEE is to provide an open source cloud native Java framework and set of specifications, TCKs, and implementation. So the most important part is that it's driven by the community. So every time you hear in from now on the JakartaEE brand, as it is, we are talking about, as we formally know, as JavaEE. To understand why, for example, in this case, Rafael, GVR, and the Brazilian healthcare system chooses JakartaEE, MicroProfile, and all these projects, Apache TomEE. We need to understand where JakartaEE is in the space of an organization. In this case, it's under the umbrella of the Eclipse Foundation. For all of those that has used the IDE Eclipse, in reality, Eclipse IDE is just one project from more than 360 projects that the Eclipse Foundation has, and you can see there is an overview PDF that you can download to understand better how much the Eclipse Foundation cares in terms of leadership, the open source projects that we currently use. I like to present this when we were designing the session with Rafael. Nowadays, I think it's very useful to understand how all these all these actors fit within one diagram. So we have the Eclipse Foundation, we have the top level project, which is EE4J, and under that project we have JakartaEE, and also there is another project which is MicroProfile. I'm gonna briefly mention for all of those of you that is the first time you're hearing this, but this is the technical context that is the backbone and the baseline that defined where the system that Rafael describes is going and moving forward with that. So in terms of Eclipse MicroProfile, is basically an open source community specification. The root of the project is to enable to Java enterprise applications the best practice in the industry for microservices. To generate also the specifications, the TCKs, and the APIs, so that allow any other vendor or open source project to implement those. And feel free to check out the microprofile.io website if you want more information. Currently, it's being implemented by different vendors that provide support, in this case, to some of the ones that are open source. Most of them open source projects that implement this. I'm not gonna go directly throughout each of the specification, but this is like 1,000 feet of what it's about MicroProfile. We have an OpenAPI. Rafael mentioned about security. We have JSON Web Token propagation, but also you start seeing common APIs that you had been used if you had been a JavaEE architect or developer. So now with JakartaEE, we base the foundation of the community based the foundation of Eclipse MicroProfile on JakartaEE. So we have CDI, JSONP, JAX-Arrays, JSONB, and obviously you can put this on top of JPA and some other frameworks that other APIs that you have been already using. So this is how the pieces of the entire recipe comes together. And then for the deployments and the implementation of MicroProfile, we have been using Apache TomEE. For all of those that haven't heard about Apache TomEE, but maybe you have heard Apache Tomcat, you can think of Apache TomEE like Apache Tomcat plus JakartaEE. Is basically built from Apache components and MicroProfile compliant. It's web profile certified in version 6. We are currently working on the JakartaEE 9. And you can follow up, contribute, and consume and make questions via the open channels and mailing list on the tomee.apache.org. In terms of the technologies of this application server that we are using in the project, we have the JaxRS MicroProfile flavor. Like I will say it, we have different flavors within the project. And all these APIs, all these specifications, if you have been developing JavaEE now with JakartaEE, we have the same, right? So these are very common specific specifications. And finally, Rafael mentioned that in the system we have a layer for security. So we are using the TriStream API gateway to, as you are reading there, to secure, but also route and load balance the microservices and the integrations that this system is now requiring more and more with other systems within the Brazil. Integration with other entities and also with other countries. What are the lessons learned that we have so far? Well, I can give you examples of the before and the after and a snip of code about a couple of specifications, in this case, the MicroProfile ones, which are the newest ones. If you have been already a JavaEE developer or you are becoming now a JakartaEE developer, you will see that you will find the code really familiar, right? So the project, the legacy project, I wouldn't say the monolithic project because the project didn't have in mind, let's move from monolithic completely to microservice architecture. As I had been saying, and also Rafael mentioned, the purpose was to start migrating new modules that require this microservice approach and a cloud native architecture. So that's what I have been presenting here and what Rafael have described. So obviously sensitive information with the project files, complex customization of how the properties was read by the system, and also how when you start thinking about how to migrate some part of your system to the cloud, then you need to realize that you will have changes in your infrastructure workflow. As Rafael described, some regions are deploying their on-premise cloud, others are opting for Google or Amazon or Oracle. So we need something that will allow us to have this in a more manageable approach.
You said Oracle, and we are moving to Postgres. So we have part in Postgres, and now part in Oracle.
Yeah, so there you go. It's like it's a living system, like I think most of the systems nowadays are, and they are requiring a lot of changes depending on their requirements. Thank you, Rafael, I forgot about that part. Thank you much. We also have the advantage of applying MicroProfile Config. What we ended up, as you're reading here, the escalation of the system, the tracking of the properties, the ability that you can change a configuration and the server pick it up on the fly, starting the containers if we are deploying on the cloud, imagine we are talking about a Docker environment variables, we can have this seamless integration between what the previous system with JavaEE root in their architecture took advantage now with MicroProfile and JakartaEE, as we were mentioning. This is a small snip of code. You will see a couple annotations that are you really familiar with. So for example, inject. And then there is one that you haven't seen yet if you haven't go to check microprofile configuration, which is the add config property, which basically is, in this example, show you how easy it is to obtain. Imagine that this is running inside of a Docker container. It will pick it up from the environment variables if you configure that to work to enable the log, and you can change that on the fly. There is also, in this case, the injection of the JSON web token. So again, this allows us to have easy development and take advantage of all that standardization and integration. Then we have also the health check and plus metrics. Before this modernization process start, we have a lot of manual process, third-party tools that were implemented by different deployments of the solution. That's why we add there dispersed monitoring. So it was really hard to trace, and this allow us to be more reactive instead of proactively checking the status of the overall system. With the health check and metrics from microprofile implementation point of view, now we provide centralized JSON-based alerts. So even though we, as Rafael mentioned, in Santa Catarina, want to have their own dashboards or their own metrics, the main source of data is coming in a standardized format, in this case JSON, and they can use the viewer that they want in order to obtain that really seamless. Since the last 3 months, it has allowed the system to be more proactive in terms of how the system is behaving. And remember that at the beginning of the session, Rafael was mentioning that, there are spikes that haven't seen before in the system. So that is being monitoring on a lifetime basis without depending on complex third-party expensive tools. Is part right now of the architecture. So that is something that the application is delivering without impacting the performance and so on. Like if instead you need to install agents or some other tools that are outside. This is again another snip of code. The new annotation that you're seeing here is the health in this case, and then the definition of what it means for us as a user of or administration of the system to say the system is health. It's not just the common, okay, it's on, off, but actually what that means. In this case, you're seeing how we can define custom health checks, like checking if the database, in this example, is up and running and how much time is taking that. And we can also aggregate different kind of a status. So for example, just because the database is on, that doesn't mean the system is working, right? If we depend on a third-party service, we can extend this, and maybe 2 or 3 more health checks will give you an okay. If all of they are okay, returning okay, that will give you a better understanding of the health of the system. So it's very extensible. And if you are interested in this part, check out the MicroProfile Health Check API. Can you describe us a little bit here, Rafael, the images that we are seeing on the screen? I know that this is the one of the latest UIs that we put in front of that, right?
Yes, we have here one system at the Federal Council. And then we check, we made an application, then call health checks, and visually we can see the results. So we have 2 examples here, and at this moment, the system is okay because we receive 200 status. And then we made an application, then we can register other endpoints to make these checks. And
as you can see here, we didn't reinvent the wheel in sense of let's build everything from the ground. We basically leveraged the the MicroProfile health check to provide us the data. And in this case, the UI is just a layer that allowed to create custom dashboard based on the current ones that the system has. So it's extendable in that way, as Rafael were mentioning, which is it has had a really great impact on the final user. There was a question that I just saw from Sergi. He's asking, hi there, I'm really interested how you're planning to implement OAuth 2.0 with JakartaEE in your system. So that is an entirely, that topic is a topic that I really like, and it's for an entire session. But we actually are in the part of the presentation when we have about what happened with JWT Authentication. So hopefully that will help you to better understand how we are actually enabling this within the legacy system. Thank you for the question, Sergi, and feel free to send more questions either throughout the chat or the dedicated Q&A sections on the platform. So what we had before was basic authentication with session management. Obviously, if we are talking about cloud deployment and all that, the challenges started to arose, like, for example, we need a stateless security, how we will manage the authentication even between microservice orchestrations, when we are talking about also from business to business point of view in terms of the architecture. That was something that was a requirement. And start stopping the necessity of have a single point of failure. So OAuth 2.0 was obviously widely adopted by that time in the industry. So we knew that from the beginning of the project that we have to find something that will allow us to integrate this type of security in the system. So after implementing, in this case, the JWT specification from MicroProfile, I think that's the key, how MicroProfile can talk each other and integrate with JavaEE or JakartaEE applications. We ended up having an stateless security. We managed to have a seamless integration between microservices, and also to keep the load of and all the benefits of OAuth 2.0, that is removing that single point of failure. This integrate also seamlessly with the API gateway that we mentioned, the TriStream API gateway. So we had, from the architecture point of view, everything that we need to allow our current or our legacy system to be modernized with this technology, OAuth 2.0, and also using the API gateway to integrate third-party systems, as Rafael will explain later. This is a snip of code about what the MicroProfile JWT specification is. You still have, the common JakartaEE, JavaEE kind of annotations. At inject, we are injecting the JSON Web Token that the container is providing that to us. We don't need to do any other heavy code integration. Obviously, you can configure this with MicroProfile Config, which is what you are seeing here, for example, for the log enable. And basically, then you use the token servers to get information. You can, in this example, we are checking one of the claims of the JWT that we are obtaining. In this case, if the email is present, or if not, we will send a message indicating that the JWT is lacking. This is just an example, but as you can see, it's easy to read Java code without any much plumbing. The configuration is pretty straightforward when you start utilizing the MicroProfile JWT. And again, this is the specification. There is the TCK, the test compatibility kit, and you have the different open source projects and also vendors who support those projects to implement this. So effectively speaking, as you were used to it with JavaEE applications, JakartaEE shares the same concept of deployed on different application servers depending on your needs. Rafael, as already explained, different consoles have different requirements, and in this case, MicroProfile also shared that integration and that standardization. In terms of security, we are having the same. An example of how with the COVID-19 response, this was really helpful. Rafael, can you explain us how you in less than 8 days you were able to integrate these third-party systems with the OAuth 2 security schema and all what we have seen within the current system?
So our client has a subscription with some medical knowledge databases to practice clinic practical, rehabilitation, research in general. And then they wanted to deliver to their doctors, registered doctors, the access. But they have only one password for these systems. And then we hide this the real endpoint with password and things like that inside gateway. And then our system, depends if the guy is logging on our system, authenticated, they can access or don't access. And then we have control who's the guy that are using our data, the subscription, who's the doctor that are making some research between using the system of the council. So now they have the full control of the use of this subscription, and provide their doctors with one more solution.
Yeah, and you see, as Rafael mentioned, the advantage here is that all the specification that we just saw, the reporting and the capability of seeing health checks and also metrics, all that is integrated. So it's not just the fact that we need to allow third-party integration so people can kind of start looking at this with their existing credentials and second-factor authentication, but also let's analyze how this is being used. So that is something.
We have more integrations like federal companies that database with Google Authenticator API, credit card APIs. So now we have we have almost 10 integrations in the whole systems with very easy steps to gain this to use this feature.
Great. Then we also we also are going to present one of the last specifications that we had for this presentation, which is the REST client. Before it was a type and a not type safe client, the type of integrations. There was this exchange about how the service needs to be understood, even between the system. Because again, if we have the monolithic and we are modernizing or migrating or creating new modules, but in a microservice approach, still they need to interact with each other, and we need a way, obviously, to facilitate to the developer team how to integrate this, how to monitoring them, and so on. So as you can see, not the best reusability of code, and I think most of you sometimes go through a situation where you are actually developing the service, but at the same time, you need to create the consumer of that service, not just for your tests, but also to provide not just the API, but also how the client, the consumer API will interact. So we needed to be agile in order to not redo the same work twice. So with the REST client API, the main advantage, if that is type-safe, it allows us to have a type-safe approach. We basically just reuse the interfaces, or we create interfaces based on the REST endpoints code that we already have. So that allows you to have an easy change in your between the updates or the increase of functionality. So the client change at the same time the main code is changing. So you don't need to keep try to keep matching what the client should consume if you have new features, but because they are really close together, so they can iterate it. And then as a collateral huge benefit, the JWT propagation and integration is something really, really simple to actually add if you are using this. Let's see this example. In this case, we have this interface, Cipro Search Client. You only have this annotation, the new one that is registered REST client, which actually we literally copy our endpoints. We convert that into interface, and just by adding that annotation, and then because it's an interface, you don't have the main logic, but just the signature of the methods. Just with this, you already have what you need in order to use this client in your code. So the next slide will show us how we actually use this interface to start consuming our own services on another microservice. So the line, I don't know if you can see my mouse, but yes, I see you can see. So we have, for example, another one, the doctor resource client. This is very familiar. These are no new annotation. These are the ones that we have been using in the last 20 years. So this hasn't changed anything. The only thing here is that we are adding the register REST client, which is actually saying, and you can see the package or Eclipse.microprofile REST client injection register REST client. We are just telling to the container that, hey, this is gonna be how my client is going to consume that JAX REST service. And in the way you use it is even more simpler. Basically, you use the common inject annotation, and this is the new annotation, the REST client annotation, in which you just specify the previous interface that we defined. But just from that, we leverage the container, the ability to build our client based on the interface, and then we can start using as in a normal Java natural workflow and code workflow, the interaction with that. So once we have declared here our client and inject the reference to that client, which basically we just say, okay, give me the list of doctors, and he knows where to find that. Because if we go back, you will see that we have the paths. We can send parameters and so on. So it's still, it's a really natural, I will say, a step for our developers, how we can approach now with this REST client capabilities, how to persist new doctor. A new example is as simple as just you create the object, you maybe process something that you want, and then you send that in a type safe. Let me check if we have other questions. Okay, no, so far. In terms of OpenAPI, this is really common, how you document your microservices, how you document your REST services, I will say. We also needed to have a way to provide documentation for third-party integrations that wanted to consume our APIs. Before, we have the legacy system didn't have well documented. It was not standardized. Remember, this was more than 10 years ago. So yeah, we were coming from SOAP web services and how the WSDL files and all that. But for the cloud part of the system that we had been developing and migrating from the main monolithic, well, we needed obviously to have a REST approach, and in this case, OpenAPI was the response, previously known as Swagger. If you are familiar with Swagger, well, OpenAPI from version 3.0 is the standard for that. What we gain after that, after the implementation of OpenAPI, well, first we have the standardization. We were worried about how much plumbing we will need to do in our existing code to allow this to work. But we were really surprised to find that the changes was not something ridiculous with a amount of effort. It was really simple. I will say it, obviously, when you are extending your current annotation with more annotations, sometimes the code start to be a little bit bigger. So you need to define at least the minimum or create some other annotations in order to provide that automatically. But then it allows us to have an API first design approach, which is something that most of companies in the last 2 years have been fighting with. This is not simple to have this mind switch about, okay, let's design first the REST API and then just develop the test, and finally we actually are going to develop the API. And mainly in these times when 3 months ago Brazil had to develop a couple of new endpoints, how we can respond to that. So I wouldn't say that all has been be happy days. It has been times when we have to go straight to the code, but the OpenAPI allows us to generate automatically once we finish coding at least the endpoint structure without the beef or the actual logic code. Just by having that, we can send already the API, the OpenAPI documentation to third-party systems that will consume our APIs, so they can start creating their clients if they are in different programming languages. And in the case when they are using Java, well, remember the MicroProfile REST client. So it's really easy. At the same time, you just create the definition of what are the endpoints of your service. You can create the interface and create from that the API that we give to these third-party services, the documentation with OpenAPI, and then we can, in parallel, we can start to actually code the logic of what the endpoint should do. We can just mock up services and all that, but again, this is just an example of how this will allow us to easily perform this kind of migration to the cloud. If you're familiar with OpenAPI, well, it's basically what you're seeing here, new annotations in this snip of code. For example, the operation, the description of the operation, what this API is intended to do, where are the codes that you're going to have, and descriptions about that. And we can define schemas, classes. And from there, the get annotation that produces the path that is JAX REST. So that hasn't changed. This is the same. So basically, we are just instrumenting a little bit. We're just adding a couple of more annotations to our existing code in order to generate the OpenAPI documentation for our REST endpoints. This is just a screenshot of a common used OpenAPI UI. When you can actually test your services while you are coding, or actually you can publish this with these third parties, organizations, or entities who wants to consume our endpoints. Rafael is going to describe us a little bit. We have been mentioning that in the last 3 months we had been able to create new systems, new APIs in really short period of time.
Yes. Next, please. So the COVID quarantine starts here in end of March, and then the government make a temporary law that supports telemedicine, because doctors stay at home in home office and can make prescriptions or consultations to their patients. So they make a special law to regulate that. And then we receive a call April the 2nd night to make a system to doctors make the prescriptions and notes. How do I say, Cesar? Atestado médico.
The prescriptions? How to make the prescriptions?
Prescriptions and document that the guy make some. The guy are sick and have to stay home. Do you know?
Yeah, the work permission letter to justify that a person was either commuting from their house to the pharmacy, or to prove to their employers that he couldn't work on site, right?
So doctors have to use some platform, some system that they can make prescription, put some information about the patients, but this is must be digital, online, not in hand. So we made a system that the doctor emits a digital prescription to the patients, and the patient receives this in WhatsApp or email, and then the patient go to pharmacy and present the prescription. So the pharmacy can check the validation if that prescription is real. And the whole system, we made it in 5 days. Why? Because we had a platform already running with monitoring, with all those stuff that Cesar showed to us, and we make integration with the doctor space. So the doctor used the login of our system, our base system. We can check in the federal company's database if that pharmacy is good, and the special database of pharmacy database, we can integrate with Google Authenticator to put more security in the system with two-factor authentication, and we put encryption of sensitive data, because now we are dealing with some medicine very strong, and we have to prevent fraud. We have to prevent the data of the patients. It's very, very dangerous data to deal.
Yeah. So I think the main takeaway here is that, the response needed to be fast. People needed their medicines. The government needed to be sure that the medicines were allocated to the actual patient that needed. And at the same time, this integration with the pharmacy didn't exist before. The pharmacies had their own systems. So it was a huge effort previous to that 5 days of development in terms of, having all the pharmacies all together, see which system they have, which kind of integration they were already offering to us. And then we needed to present to them the integration, the documentation, and all that. I see there is a question also from Sergi. I will address that later. It's kind of related to this because it will touch the REST client. But yes, as Rafael already described, is a sizable workflow, but every time you need to integrate something in computer science, it's gonna have challenges, and so far we have been able to have this quick response due to current circumstances that the country has.
Yes. So the next, and here's some code. I put this code here, but you can show. We use the converter, attribute converter of the JPA. This is how we encrypt the data. And the next slide, I'm sure we made it almost 20,000 prescriptions since April 8th. So the system is highly used, and almost 65,000 validations. So the patients and the pharmacy get the prescription, digital prescription, and need to validate them.
Yeah, so they use a QR code. Either you go to the pharmacy, and in the pharmacy they read this QR code that basically validates again our system. If that medicine was already delivered to another patient, or if it's still valid, of if you your doctor prescribe you or extend you the amount of medicine that you will need. So We have. Thank you very much. We are just at the edge of the hour. We have a really good question. Good question about Sergi. Thank you much for the question about DTOs, doctors, for example. Are you sure DTOs between services or keeping separate DTOs for client and server? Really good question. So basically, yeah, the DTO and the client needs to be on a separate API or jar file, I will say, because eventually, if you are delivering your client API, that will need to have the DTO. So if you create a second DTO, you will need again to code one change in the server DTO needs to be also be implemented on the client DTO. So the DTO needs to be the same for both.
Yes.
Okay. Okay. If we don't have any other questions, thank you so much. Thank you, Rafael. I think I hope this session will allow you to the viewers to not understand in the first part of the presentation the complexity that we deal within the system, and actually also within the current needs the Brazil has, and how we are trying to keep moving forward this living system with modern technologies that we just saw. So yeah, that's pretty much from my part.
Awesome. Thank you both so much for presenting. Oh, sorry, Rafael, did you have something?
No, so thank you, Cesar. Thank you, the community. Thank you, people attending this talk for the opportunity.
Thank you, everyone. Have a great day.
Thank you much.
Bye.
Bye.
Bye.